Hello and welcome to this video. Today we're going to be talking about multicast domain name service, or mDNS. Uh, for the agenda today, we'll do an overview of the feature, look at some examples, we'll go over the details of it, see how it's configured, learn about how to troubleshoot it, and then we'll have a quick demo on it. So mDNS is part of the, we've enhanced it for AOS-CX 10.9. So this is part of our AOS-CX 10.09 transfer of information, or TOI. So multicast DNS, or mDNS, provides the ability for devices to discover various servers or services such as Apple printers, Apple TV, Google's Chromecast across VLANs using the multicast DNS or mDNS service discovery process, what we call an AOS-CX mDNS SD. So mDNS provides the ability to perform DNS-like operations on the local link without having a typical unicast DNS server configured and stood up. Basically, mDNS uses a reflection mechanism which allows these clients to discover these various servers across VLANs that are filtered. Basically, they're speaking to a multicast group, and so the services use multicast to discover each other across these different VLANs, and then the mDNS SD profile on the switch can filter those services based on permit or deny statements that are configured in the policy. So AOS-CX 10.9 enhances the support for mDNS on the Aruba CX 8325, 8360, and 10,000 switch platforms. Previously, it was on the 6200, 6300, and 6400 devices. So one of the more common applications that we see with mDNS is Apple's AirPlay. There's a lot of Apple devices out there. There's many examples where AirPlay is used. If someone needs to mirror their device to a TV, they can use their iPad, their phone, or MacBook to be able to do that. With an Apple TV, you can mirror that device to an Apple TV. So in this example here, I have an Apple TV connected to my switch. I have an 8325 that is doing mDNS, acting as the mDNS gateway. Both switches are in different VLANs, and then I have an AP connected to another switch going through a router, which I have my iPad connected to the AP wirelessly. So then here, if we look at the pictures, the top picture is my Apple TV that we can see the settings for it. And then the bottom picture is after I've turned on screen mirroring to my iPad. I can see on that same TV that I have the iPad setting there. We can see that it's Ashley's iPad, Ashley being my wife, so that the iPad is screen mirroring effectively to the Apple TV. So other examples with rather than AirPlay, most Apple devices will use AirPlay. We've covered that. Apple printers using Bonjour also works with AirPlay. That was kind of the precursor to AirPlay, but Apple printers use mDNS to talk to each other. Google Chromecast uses mDNS from an Android phone or Android device to the Google Chromecast connected to a TV. Windows Network Printer Discovery uses mDNS. Anything with Miracast, Android uses that quite a bit to do screen mirroring from a personal device to a TV as well. So these are all major examples of using mDNS in the real world. So let's take a look at some of the nuts and bolts of mDNS. Basically, it uses, as I mentioned earlier, a reflection mechanism. So mDNS packets are received in one VLAN, and then they're then reflected via multicast to a multicast group to all the other mDNS SD-enabled VLANs based on the configuration filters that are configured, which is part of the mDNS SD profile. So then DNS records are used to communicate. So when the request is generated, it's managed by the profile, filtered out if it needed to be, and then if it needs to be reflected, that type of service like the AirPlay service is reflected out to the other mDNS-enabled VLANs, and any devices will honor that request. So there's only packets containing the pointer service text, and address records will be supported for reflection. So the pointer record contains a service name to service instance name mapping. The service record contains service instance name to UDP TCP port number and host name mapping. The text record contains more information about the service instance, such as vendor information. And then the address record contains the host name to host IP address mapping. So when a client in a VLAN sends a service request pointer record, that same record will be reflected to all the other mDNS SD enabled VLANs. So we can see here in this packet capture that the query has been sent out by the iPad who's requesting to connect to the AirPlay. And then we can see as part of the query in the packet capture that it's being joined to this multicast group, which is 224.00251, which is reserved for mDNS. That's part of the standard. And that IP is used specifically for mDNS. So once the query is sent out, then it's responded to by the switch, which has a device ready to go configured for mDNS. And then we can see that the AirPlay TCP local service is being responded to as part of the mDNS packet process. So for scale, there's a max of 256 configurable mDNS VLANs on the 6300, 6400, 8325, 8360, and 10,000 switch platforms. It's 128 VLANs on the 6200 switch platform. Some caveats. So it's not supported on the 6000, 6100, 8320, and 8400 platforms currently. There's no IPv6 mDNS service discovery. Filtering is applied only on the egress mDNS packets. And filtering is performed only based on any of the parameters extracted in the first DNS record. SSDP-based discovery is not supported. mDNS packets are rate limited by COPP or control plane policing at 150 packets per second by default. So only enable debugging for troubleshooting. So if you try to debug at high scale, you could run into high CPU utilizations and high CPU utilization and slow the system down. So it's important to be aware of that and only use debugging when absolutely necessary for troubleshooting purposes. So to configure mDNS, first we need to configure the mDNS service profile and services. So we do that using the mDNS SD service command. And then we need to configure the specific IDs or service IDs that we want to filter on as part of that profile. So in this one, I'm using Apple TV, and the ones usually Apple TV uses is AirPlay, Apple TV V2, and ROAP. And then after we've configured our profile and services, first, this is the service that we're configuring and the specific services, TCP services that we're doing, which is airplay.tcp, Apple TV v2.tcp, and roap.tcp. And then next we want to actually configure the profile. Then we'll give the action for those services. So the profile we use using the mDNS SD profile command. And then we can permit or deny the service name, which we just created in the previous command. Finally, we want to enable mDNS globally and at the interface. So we use the mDNS SD enable command globally, and then under the interface, we have to enable the command mDNS SD as well as the mDNS SD apply profile, which we have already created the profile. So once we've enabled all those commands, we're ready to go. Let's take a look at troubleshooting this and what the flow is when we're troubleshooting. Some of the important ideas that you want to have when you're troubleshooting this is make sure you have a topology diagram, of course, because it's really hard to troubleshoot unless you can visually see what it looks like. You want to make sure, if needed, you have all the appropriate interfaces labeled. If you're using IP addresses in this case, we just really need to be concerned about VLANs and where they're at. So we can see the two access switches has One's in one VLAN, the other's in another VLAN. And you also want to make sure physical cabling is correct. You can use show LDP neighbor to make sure the switch is connected to the right upstream or downstream device, and also make sure that there's VLAN connectivity. If you need to put a IP address on the VLAN and test pings across it, you can do that as well. But really, the recommended troubleshooting to get down to the nitty-gritty specifically for mDNS, first we want to check and make sure mDNS services are configured correctly. We want to verify the mDNS configs, that they're correctly applied. We want to verify that we have VLAN connectivity. We want to check the hit counts of the mDNS service, and then also check debug output. So step one, we want to check mDNS services. So first thing we can do is do a show mDNS SD service entries. That'll give us all the service entries that have been learned by the switch that it's running over mDNS. So here we can see we have a services record name using the pointer record type. We have DACP, TCP local using the pointer type, AirPlay using the pointer type, iTunes control using the text type. So we can see all the records of all the mDNS services going across those VLANs by running this command. Next, we want to make sure that the correct services are applied and permitted. So if we do a show running configuration mDNS SD service, we can actually see the mDNS service that we have configured, which is called Apple TV, and then all the services that we have, service IDs that are configured under that service: AirPlay, Apple TV V2, ROAP, and then XGrid. And then we can do a show running configuration mDNS profile to validate the profiles configured. So here it'll list the profile and then the service that we have listed under the profile and whether it's permitted or denied. So we have permit currently running on this. Then if we have it denied, we could see that in a packet capture that we wouldn't be able to see those types of services. So in this packet capture, I've denied it instead of permitted it. So there'll just be a deny command here. And we can see that there's no response in the response packet to airplay.tcp. It's actually looking for this companion link, so off a completely separate service. It's not seeing any type of response from the AirPlay TCP service because those are the ones that the switch can actually filter on. So if the switch doesn't have a record of it, because there's only a few of them in there, it'll by default allow any other service over the mDNS gateway, over the mDNS enabled VLANs. So the next step is we want to make sure that the configs are correctly applied. So we can do, on this first command here, we can do a show mDNS SD summary. We can see that it's globally been enabled and that on both VLANs it is also enabled with the correct profile. If we want to enable it at the interface level, we can do a show run interface, and then we can see that the mDNS SD command is there. That means it's enabled on that interface, and that the mDNS SD profile is applied correctly. Third step, since this is layer 2, we want to verify VLAN connectivity. So I did a show run on both VLAN interfaces, and so I have IP addresses configured on there, and then I can run pings across between the two VLANs to make sure I have connectivity on there successfully, that I can see I don't have any packet loss on my pings. Fourth step, we want to check the hit counts on the DNS service. So we can do a show mDNS SD statistics VLAN, and then it will show us all the VLANs if we have mDNS configured. It'll show all the VLANs and the packets, mDNS packets received, sent, and dropped across those specific VLANs if you have mDNS running. So both of our VLANs, we're using VLAN 10 and VLAN 201, and we can see that packets are being received. Some packets are being dropped probably because we had the service denied at this point, so packets aren't being received there. But that some packets are being received, which are probably services that aren't defined in our service profile, mDNS profile. And then you can do a show mDNS SD statistics profile, the profile name, and you can actually see the hit counts. So we can see we have 6 hit counts there so that the mDNS packets are actually being processed through that profile correctly. So we know it's working. And finally, we can check the debug output of our of mDNS. So we can run the command debug mDNS all. We can send that to the debug buffer if we so choose. I like doing that. And then I can do a show debug buffer reverse, which will give me the last entries first. And so what we're looking for in the debug buffer, so if the service is permitted or denied, in our case, we have it denied. We have it set to deny so that we can see in bold here that our service packets have been denied. So that's what we're looking for as a fail, which means that we were denying anything on Apple TV. It's filtering, F-I-L-T, it's filtering on the Apple TV service ID and that it's being dropped or failed. If permitted, we would see the entries being parsed. So we could see something like parsing the record 4 name, and then we'd see the service entry. Parsing the record 3 name, AirPlay. So there's our AirPlay that we denied. Now we're permitting it. So that's what we'd be looking for in the debug buffer, the most common ways of troubleshooting mDNS. All right, let's do a quick demo here of mDNS. So here is my switch. So we did some show commands earlier. So if I come down here and just do a show running config. So here I have mDNS enabled. You want to make sure that's enabled. I have my services configured here, AirPlay, Apple TV, ROAP, and XGrid. And then I have my service applied to my profile. And I have everything permitted currently. So next thing I'm going to do is I want to copy my profile name so then I can see the statistics on that. So show mDNS SD, and we want to look at service entries, and we just see all the service entries currently that are going over my network on there. So you have a bunch of TVs in my home here, Vizio, we got AirPlay, Amazon's on here, probably the Alexa. So there's all kinds of different, Google Cast, got all kinds of different devices on here. But we're going to be focused for this demo specifically with the AirPlay and ROAP. Those are two of the primary ones with AirPlay. So what I'm going to do is log into my tablet here, and then I'm going to turn on screen mirroring, make sure it goes to my Apple TV. So currently that's working. And then what I can do is we can see all the service entries. Let's just take one more look at that command, see if anything's changed there. Like we got a new AirPlay up here. So yeah, we got a couple of them doing AirPlay. Probably a lot of devices on my network are AirPlay capable. And so you can see all the Samsung TVs are AirPlay. We got a lot of TVs in this house. So we got a lot of devices that are enabled for AirPlay. So I have my iPad's currently screen sharing to the Apple TV, so that's good. So we can look at some of the statistics from the switch to verify that. We can do it by VLAN, so we can see that we have a lot of packets being received, sent, dropped because maybe the switch doesn't know what to do with them or it was filtered at one point. But we definitely have packets going over, especially VLAN 100 because that's incrementing there. And so we can actively see that going on. We can also look from the profile perspective. Whoops, what was the mDNS demo? We can see the hit counts currently happening. So we have AirPlay traffic hitting that mDNS profile. So we can see that the hit counts are going through. See if that increments. Maybe I'll stop. Let me stop sharing. Stop mirroring. And then we'll start it again. See if that incremented. Yep, see that one incremented. So I stopped sharing, started it again, and we can see that it's incrementing. So we can verify mDNS is currently working on our switch. Some other useful command, so you can do a summary. That's a handy one that'll show you everything that's been enabled, globally enabled. It's been enabled on the SVIs with the correct profile that's being applied. So we can verify that it works that way. I don't think, so we can actually get down to service ID if we wanted to. We find one of the service IDs from up above. Scroll up higher, we can, let's find an AirPlay one. There, this is ROAP is a good one to use. We'll just copy that and then apply it. So then we can see where all the MAC addresses and all the devices records that it's asking for that service ID on. So we have different records, pointer record, service record, text record, and a record. So all 4 types of records are being reflected on that service. So we can look at it by service ID. We can also look at the service entries by record type as well. So if we want to see all the A records, just type A. Pointer records, we can type pointer. So that's mDNS. So really the key feature with mDNS on AOS-CX 10.09 is that it's now supported on the 8325, 8360, and 10,000 switch series. Reason for that, we see those in core and aggregation in the campus applications where those need to act as a gateway, a VLAN gateway, and so customers have needed mDNS to act on those switches, not only on the access switches. So that's the thought process behind that. So I hope this is beneficial. Any questions, please don't hesitate to reach out.